For this week discussion, I will talk about the architecture of the information system for the point of sale that was given by the professor. On this image, as you can see, we got 4 different clients are trying to communicate to the internet service provider. And on one location, it has a server, has a backup. On the other location, it does not have a server, and so the communication can be messy. There's no kind of firewall protection to protect any threat coming from the inside or the outside when communication are being um, flowing back and forth in the network. So in the next couple of slices, I'm going to talk about what type of structure will improve this process, and then what needs to be removed, what needs to be added in order to increase the speed, make it safer for the client to request information to the server, and then receive that information back. Okay. The structure that I am proposing, it's called the client-server structure. So what is a client-server structure? A client-server structure is an architect that in which the servers, which is the host, delivers and then manages most of the resources and then services to be consumed by the client. So in this case, we got 6 computers on this image here, um, and then they're trying to communicate to the server. So we got clients on one end, and then it's trying to communicate to the host. So usually this structure helps with when there's one or more client trying to connect to the central server over a network or the internet. Okay. The client server architecture is kind of like a producer slash consumer. The server houses and provides high-end computing intensive services to the client demand. So whenever these clients are sending a request, the server then send back what is being requested so that it can produce information on the screen or provide certain data that the user is trying to receive. Okay. Within the client server structure, it it also allow you to have a continuous data backup in the cloud. This will then improve the process where the system can back up wherever you go. So if we look back in the original image here, we see that location A has a server and has a manual backup. However, location B does not. So with the new client server structure, it allows all clients to communicate at any time, and then within that communication, it is being back up in the cloud automatically. Okay. Then in the client server structure, I will add a public firewall to protect any threat, any type of scam or virus that is trying to attack the client or the actual the local network. So when the client trying to send information outside the cloud, it has been protected, it been analyzes, and then once it's been secure, then they get passed to the host, which then they're gonna send back the request. So once it go back, before it go back to the client, it will pass through the firewall one more time. This information will then get analyzed, and then if it's secure, then we'll get sent back to the client. Then the other factors that I would change is that in the original image, we have devices that are using wire. So to make the communication process quicker between the client and the host, we want to make everything become wireless. And as you can see, we can, let me go back to original. We got the client, we got a barcode scanner, barcode printer. Everything will works quicker if it's wireless. Okay. In order to make the wireless system work efficiency, we want to improve the internet speed. In the original image, we see that the client is using a DSL internet type, but in order to improve the communication and then the wireless devices, we want to improve the internet to the fast broadband. Then the last thing I want to add is the tablets and smartphones. By adding the tablets and smartphones, the consumer can use the information anywhere to go because it's been connected to one host. And then that information is also being backed up by the cloud. So if one client gets shut down, the smartphone, the tablets are the backup to access the data anytime, anywhere.